You didn't remove any microplastics, not from your body anyway. There's a video with over 70 million combined views right now claiming 2 foods can pull 90% of microplastics out of you. I read the actual study it's based on. Nobody in that study ate anything. Here's what really happened, and why the confusion matters more than you'd think. Let's start with what's real, because there is a real study here, and it's genuinely interesting. In April 2025, researchers at Tarleton State University in Texas published a paper in the journal ACS Omega. They tested whether extracts from 2 plants, okra and fenugreek, could pull microplastic particles out of water. Not out of a person, out of water. Here's how they did it, and this part matters. They didn't just use clean lab water. They tested 2 kinds of samples: simulated water, spiked with a known amount of polystyrene microplastic beads, and real water, collected from oceans, groundwater wells, and rivers around Houston, Lubbock, and Arath County, Texas. They soaked sliced okra pods and blended fenugreek seeds, extracted the natural plant sugars, called polysaccharides, dried them into powder, and added that powder directly into the contaminated water. Concentrations from 0.5 gram to 2 grams per liter. Contact time from 5 minutes up to 90. The best result, fenugreek at 1 gram per liter removed about 89% of microplastics from groundwater samples in 30 to 60 minutes. That's the whole procedure. Powder goes into a jar of water. Water gets tested before and after. That's it. Now, why does that even work? Because the chemistry is real, and once you understand it, you'll see exactly where the story breaks. Those plant sugars, the polysaccharides, are long, sticky, tangled molecules. Microplastic particles floating in water carry a faint electrical charge that keeps them apart, suspended, refusing to settle. When you add these sugar chains, they do 2 things. First, they neutralize some of that charge so the particles stop repelling each other. Second, and this is the key part, a single long molecule can grab onto several particles at once, physically bridging them together. Engineers actually call this bridging flocculation. The particles clump into bigger and bigger clusters, the clusters get heavy, and gravity does the rest. They sink, then you pour off or filter the clean water on top. This isn't fringe science. It's the exact same principle behind the chemicals already used in municipal water treatment plants. The researchers were directly comparing okra and fenugreek against polyacrylamide, a synthetic polymer used for this job worldwide, and they found the plant versions worked just as well or better, and they're biodegradable and non-toxic. That's a legitimately useful finding. For water treatment engineering, it has nothing to do with what happens when you eat okra. Here's the gap nobody selling the viral version wants to talk about. A jar of water is not a stomach. In the study, the powder is mixed directly into contaminated water, given up to 90 minutes of contact time, and then the clumped particles are physically removed, filtered, or poured off. When you eat okra, none of that happens. There's no external clumping and removal step. There's no before and after water sample. You are not filtering your bloodstream. The study never tested ingestion. It never measured microplastics in blood, tissue, or stool before and after eating anything. It's not a detox study. It's not even a nutrition study. It's an environmental engineering study about cleaning up contaminated water sources. And here's the part that really exposes the confusion. We actually do have solid evidence for physically removing microplastics from water. Earlier in 2024, a team published a study in Environmental Science and Technology Letters showing that if you take hard tap water, boil it for 5 minutes, let it cool, and filter out the sediment, you remove up to 80, even 90% of the microplastics. The mechanism is beautiful and simple. When you heat hard water, dissolved minerals like calcium carbonate, the same stuff that forms limescale in your kettle, crystallize out. And as they do, they trap the plastic particles inside those little mineral crusts. You filter out the crust, the plastic goes with it. Notice what that has in common with the okra study and with the water treatment plant. Every single method that actually removes microplastics does it outside the body, in the water, with a physical removal step at the end. There is no version of this where you swallow something and it goes looking for plastic in your organs. That's just not how any of this works. So where does the detox claim actually come from? This is worth walking through because it's a pattern you'll see again and again with viral health claims. It's basically a game of telephone. A real study gets published with a genuinely impressive number, 90% removal. A wellness account picks it up and, to make it shareable, quietly drops 3 words: from contaminated water. Now it's Okra and fenugreek remove 90% of microplastics. The next person adds from your body, because that's the version people actually want to hear. The next one turns it into a recipe. By the time it hits 70 million views, it even cites the real study with a real DOIE, which is exactly what makes it so convincing. Nobody in that chain necessarily lied on purpose. They each just softened one detail, and the details they softened were the only ones that mattered: what removal meant and what it was removed from. Now, to be fair to the researchers and to you, this doesn't mean nothing is known about microplastics and the human body. It means this particular study isn't where that evidence lives. Separately, there's early research, including a 2026 study on a gut bacteria strain found in fermented foods like kimchi, suggesting certain bacteria can bind microplastic particles in a lab setting. But that work was done in mice, not humans, and it's about one specific bacterial strain, not eating kimchi. It's a plausible research direction. It is not a demonstrated human detox method. The honest scientific position is that we do not yet have solid human data showing any food reliably lowers microplastic levels in the body, not because it's impossible, but because it hasn't been shown. And if you want a sense of the scale of what we're actually dealing with, look at where these particles come from in the first place. In January 2024, researchers at Columbia University published the first real count of nanoplastics in bottled water. The particles so small earlier studies couldn't even see them. The average liter of bottled water contained around 240,000 plastic fragments. About 90% of them were nanoplastics, small enough to potentially cross into cells. That's 10 to 100 times more than anyone had measured before, because the tools finally got good enough to see them. It reframes the whole question. The issue isn't finding a magic food to scrub plastic back out. The issue is how much is getting in and from where, and a lot of it comes from the containers themselves, and especially heat. In 2023, a team at the University of Nebraska tested common plastic food containers and pouches. When they microwaved them, some released in the worst cases over 2 billion nanoplastics and 4 million microplastics from a single square centimeter of container in a few minutes. Even just sitting in the fridge or at room temperature, the containers shed particles over time. Heat and plastic and food is the combination that does the most damage, and it's completely within your control. So what do you actually do with all this? A few honest, boring, genuinely useful takeaways. If your goal is less microplastic in your body, the evidence points at the intake side, not a detox side. Don't microwave food in plastic. Move it to glass or ceramic first. Be cautious about hot drinks in plastic or plastic-lined cups. If you rely on bottled water, know that filtered or, based on that boiling study, boiled and filtered hard tap water may actually carry less. None of that is exotic, and none of it involves swallowing a vegetable and hoping. If you're interested in the water treatment angle specifically, the okra and fenugreek research is genuinely promising for large-scale or household filtration someday, but it was jar-scale lab and field testing, not a product you can buy yet. And the meta lesson, the one worth keeping long after you've forgotten the okra, when a health claim cites a real study, that is a good sign. But it's the beginning of the fact check, not the end. A real citation is not the same as an honest summary. The question to ask is always the one this whole video answered. What did the study actually measure, and does the claim still match once you know? If you want to go deeper on what's actually known about microplastics in food and water, that's exactly where the next video in this series picks up. Links on screen now. And if a viral health claim has ever made you want a second opinion before you trust it, that instinct is exactly right. That's what this channel is for. Subscribe if you want more of these breakdowns.